All right, welcome to Computer Science 1015, Machine Learning with Python. So this is the class we're going to be doing. First thing we're going to be studying is Python itself and how to understand it and make it work. Then we're going to be using a thing called Tensorflow, and we're going to be working on machine learning. Python is an ideally suited language for learning machine learning. Now, who am I? I'm Professor Philip Schlump. And my background, very quickly, I'm going to have a podcast on this, but my background is I've spent 30 years in industry developing and building these tools as opposed to being teaching, and now I've returned here to the University of Wyoming and I'm teaching. So I have a background out of industry, not out of academia. It's a very practical background. So in this class, what we're going to be doing is learning Python, but we're going to be learning it in a very precise way, as in a software engineering methodology for learning Python. Now, there's a whole bunch of different steps we're going to go through in the process of learning Python, but I'm today going to start out with a demo that is where your knowledge is going to be down here at the end of learning Python. So when you see the demo and I run through it, don't panic, because this is where we're going to. And we're going to take the demo and we're going to break it down in pieces and learn each one of the pieces. Now, when I say software engineering, we're going to be working on a lot of testing. And we're going to work on things that aren't the development of the code itself. They're how do you go through the process of building a program. Now, an average programmer will write about 6,200 lines of code a year in industry. If you look at all the software developers in the United States, that's the kind of number you're looking at. And it's reasonable, that's a fair chunk of code. If you have a process, you can improve this. On an average year, I write around 120,000 lines of code, because I have a process that leads me through all of these pieces. Last week I produced a website that handles QR codes. They're these little barcodes, with a little square thing in them that you see on packages. And it does a bunch of stuff with QR codes for a product, and collectively that website and that is around 10,000 lines of code that was produced in just over a week. So this is the kind of difference when you have a process and you understand what you're going to be going about doing to produce code. So these things that I'm talking about, like automated testing and planning and design and how they work together, those are the things that get you from up here to down here. So that is the first section that we're going to be doing in this class, which is learning Python. The second section is going to be on machine learning. And what we're going to do is we're going to take our level of knowledge here and we're going to include a game. The game is in the textbook, the source code for it. So the textbook is basically required, so you've got the source code for the game. But it's going to give you a bigger project to go through and test and work through. And when we implement the game, then we're going to do some machine learning, and we're going to use machine learning, specifically Tensorflow, to run the game and win the game. So you go, yeah, so we made a game and we made a program, run the game. This process right here, this collective process, is the exact same set of code, basically, that Google Waymo uses to do self-driving cars. Now, they've got a huge test data set, millions and millions and millions of images, and they have lots of people working on making certain that the vehicles are doing the right thing and stuff like that. Whereas we're just going to build a game. But the concepts and the code involved in this are exactly the same as what they do for self-driving cars. Now, in the process, we're going to take the machine learning and we're going to do some other things. We're going to work up to the level of running that game. We're going to do some image classification. Image classification is some really fun stuff. It can allow you to identify all sorts of things. There's a person at MIT working on image classification to identify melanomas and breast cancer. And they're getting better results from machine learning than the best radiologists in the world. So image classification in and of itself is really useful. But we can take those classifications of images and we can actually use it to run things in the real world. So, Philip Schlunk. My phone number, in case you have an emergency, is 720-209-7888. You need to send me an SMS message first with who you are and what class you're in, so that I know who you are, because I get a fair amount of robocalls for several reasons, and consequently, if I don't have you in my phone book, I'm unlikely to answer any calls. I'm old enough and in that generation where it's legitimate to give me a voice call. So, I'm not going to take it as overly shocking to actually, if you sent me a message, said you're in this class, I'm not going to be shocked if you call me and set up a voice thing. My email is pschlump@uwyo.edu. So there's my email. It's in the syllabus, and also the instructions for sending me an SMS message. Now, this isn't the most entertaining, but the University of Wyoming requires that I go through with you what the requirements are for getting grades in the class. And let's do that real quick. In this class, the grades are on page 5 in the syllabus. What it takes to get an A, and it's a certain number of points. 3,400 points to get an A. Now, most of this, 80% of it comes from the homework. So most of your grade for the semester is going to come out of doing the homework itself, not from the midterm and final, which are each worth about 10% of your semester grade, 20% divided by 2. Now, because we're doing this as a software engineering thing, your homeworks have tests. So you should have no doubt that if you've passed the test for the homework, if the automated test works, that you're going to get 100% of the grade for that homework. That should not be a mystery to you. The homeworks have specific due dates, although the due dates may wiggle a little bit over the course of the semester. So this combination means that you should really get an A in the class. This is not a class where, you folks are smart, you're college students, so you ought to get good grades in this class. Collectively, okay, this means that if you did all the homeworks and you got all the grades on it, you would basically have a B for the semester without taking any tests. So the difference between getting a B in the class and getting an A is getting somewhere around 50% on 2 exams. And that shouldn't be too hard for any of you. Let's talk specifically about what's involved in the first homework. One of those things that you're going to go through repeatedly in classes, in life, in computer science, is you're going to need to be able to install stuff on computers. And it's never, in my opinion, the most exciting or entertaining thing, but it's a required piece. So when you go to install stuff, okay, you have to have some sort of a computer that you're going to work on. And I'll do my bad drawing of a desktop computer. But you want to make that computer so that you can actually get productive work going on that computer. And we have primarily 3 packages that we're going to be using during this semester. We have Python, and the one we're using is Anaconda 3.8, and it's available to install on Linux, Windows, and Macintosh. I primarily work on a Macintosh for this class, but I do test everything on Windows as well. We have Visual Studio Code. Okay, this is different than Visual Studio, but it also is available on all 3 platforms. I'm going to build videos for you that walk you through the installation of these 2 items on both Macintosh and Windows. If anybody is working on Linux, I will work with them individually to get this installed. But you may want to watch both videos or just watch one, but basically it walks you through that. There's specific instructions in the notes, plus websites on how to install each one of these things on your computer. Now, the third package is one that goes into Python, and that's Tensorflow. And TensorFlow is developed and used by Google for doing things like self-driving cars. TensorFlow is, it's a pretty big package, but it works well with Anaconda Python. So TensorFlow is coming up in this, but you don't need TensorFlow right now. TensorFlow will be along a little bit later, about midterm. We'll have to be doing yet another round of installations to get TensorFlow in. So these are the two that you need right now. Now, what do I mean by productive on your computer? Productive. It means that you can actually go out and run stuff on your computer and get it to run, and you can edit and change code and run tests. There are some websites that you're going to need to become familiar with across the course of this semester. WyoWeb for submitting your homework. This is also where you'll be able to find things like the lecture notes, and this is where the tests will be. So there is that, and also a thing called Github. Github is a business owned by Microsoft these days that is a source code sharing and repository. This is where I develop all of the lecture notes and where I put the first versions of everything is going to show up on GitHub. If we distribute code for you to use in class, you'll go to GitHub and get that. So we're going to go through some lectures on how to use Git and how to interact with GitHub. There are other services like GitHub, like there's GitLab, and I also use GitLab. But we'll work on this one, and a bunch of the stuff is in common between the two. Now, when I started out programming, I worked on a computer terminal. You know, it had a little prompt and you ran something like an editor. And you had some file.py. And you edited your file, and when you got done, then you'd run something like Python on f.py and run it. And you'd sit here in a little kind of a loop, working back and forth between these two things, editing your code, running your code. And you're not going to get completely away from this. This command line interface is something that's going to show up, yes, in stuff that you're going to use. Now, we're going to use this command line interface a little bit for installing things like Visual Studio Code, quite likely. But in Visual Studio Code, it shows up down here in a little window in the Visual Studio Code under some circumstances. Now, what is this command line? It's a programming language of its own. In this particular case, it's a programming language called Bash on most systems. And when we use GitHub, we're also going to use the command line and Bash. And it's another programming language that you're going to have to learn across the course of this semester. Not a huge amount about it. It's an interactive language that you actually type stuff in and you get back a response. So we're going to have to learn how that works enough to get through GitHub, enough to get our software installed and work with it. Those are important pieces that are coming up in this class. Now in the syllabus, page 4, in the syllabus on page 4, there's a list of when the homeworks and when the midterms are due. We do have a late policy in this class. I'm taking 10% off per day for stuff being late, although I will make exceptions if you're working on something, like we're trying to get your software installed on your computer and we haven't quite gotten there yet. So there may be some exceptions, but it has a list on that entire page of when stuff is due and when you have to have it done. So you can plan ahead for what the work is in this class. It lists the number of points for each assignment and the due dates. On page 5, there is your letter grades and how many points you have to have for the letter grades. And on page 6 is our schedule by week for the class. So you know that in this week, if we've got something like a discussion in the class where we're all going to get together, that this is the material that I have to have listened to. This is the material lecture that I have to have gotten through before I go to this required discussion. So those are the pieces in there. After those pieces, there's some stuff that UW requires that we at least touch on. This class has a little bit different requirements than most of your other computer science classes. I have a different academic policy on what is cheating. You're expected to do academic honesty. In this class, it is okay to use things like Google to go search for answers. If you just, when you get the answer, if you copy it from the web, you note that you copy it. Now, anytime that you go out and you get some help from someone else or from the web and you use Google to search for things, I expect you to note it in your results. Add comments to it. This is where you got it. Note where it came from. You're expected to have some understanding of copyrights, as in don't violate copyrights in using other people's code. So you're going to have to look at how that is legitimate for you to use and what the licensing terms are. That's an important thing to understand going forward. Now, in other classes they may say, no, you can't copy from anyone else. You have to do your own work. That is not necessarily true in this class. You can copy. I don't mind. Now, the details on copying is this. If you copy something from someone else, I think it's legitimate for me to ask you, how does it work? Why does this, what did you learn from this? And I may interactively ask you as a part of that homework, one-on-one, okay, explain it to me line by line. Let's walk through it, and I want to know that you actually didn't just cut and paste, that you actually read it and understood what you copied. Because reading and understanding code turns out to be far more important than writing code in being a software developer. So, down here in this section at the end, there's stuff on academic policy. There is stuff on student contact, you're expected to, or class conduct. We don't have class in here, but we do have discussion groups, what your conduct is supposed to be. I expect you to go and read it. On attendance, if you don't show up, and don't listen to the lectures, you're not going to do well in this class because a lot of the material comes from the lectures. Yes, there is a textbook. Yes, you can read it, and you are expected to read it. But a good chunk of the learning happens from the lectures and the podcasts. You have to listen to them. You have to pay attention to them. What else in there? This isn't the most entertaining material. I think I said that before. But, UW requires that I go through it, and it is important because this is how you end up getting a good grade in the class. And knowing the rules to get to where you want is an important detail. Okay, so rules are an important thing because it tells you how you're going to succeed or fail. And if you just take some time to understand the rules, then it makes it much easier to get through. Okay, you don't waste time doing unnecessary work. For instance, let's say that instead of just, your mundane stuff of you want to have, what are the rules that I'm going to use in life? I'm going to go out and I'm going to get a degree in computer science. And that degree in computer science is going to lead me to a job that pays $79,500 a year. Out of that, about 1/3 is tax. And the rest I get to keep, which is, say, $50,000. That's a pretty decent amount of money. What do I do with that $50,000? Do I want to be rich? Well, I would say the first thing you ought to do with that $50,000 is pay off any student loans. The problem with student loans is that student loans, you can never default on them. So if you just pay them off and get rid of them, my mathematical models say you can do this within 1 to 2 years if you don't go out and buy a new car and have a lavish lifestyle. Now, paying them off for the rest of your life suits the bank. I would say to you, it probably doesn't suit you. You should pay them off. Now, if you take that amount of money and, if you get a nice place to rent and you buy a new car, you get good clothes and stuff like that, you're going to go out and you're going to be like your friends that are in the IT field that are new, and they're going to think you're just fine. If, on the other hand, you get a cheap place to live, and you keep the old car that you already have, and you save your money and pay off your student loans, they're going to look at you like, they're not going to think too highly of it. So, let's say you do what they don't like, and you pay it off, and you continue to save money. Now, across the course of about 6 years, you get raises, so you get up to $120,000 a year. After about 6 years, at that point, you're probably about as fully trained as you're ever going to be in this field, if you keep training into the future. And out of that, if you live economically, you can live on about $2,000 a month, saving about $5,000 a month. And in about 3 years, you can have enough money to put a down payment on a house, or you could go buy a new car for cash, or you could put a down payment on something like a duplex. Let's say you do the duplex. Now, you wait a little bit and you kick out one of the renters, move in so you don't have any rent. So now you're living on $1,200 a month because you're really only clothing and expenses and heat, which is pretty lavish for, one person living by themselves. Even a married couple can live in an apartment with $1,200 a month. And you use the rest of it to pay off the entire duplex. In 3 years, actually 3.4 years, you ought to have it paid off. Now, not only do you not have rent, but you have $1,500 a month coming in extra income, and you're well on your way to being a weird thing in this world, wealthy. Now, so you didn't follow the standard set of things that everybody does. What you did is you went off and figured out what the rules were for becoming wealthy, and you applied them. Now, you turn around and buy, say, a threeplex, okay? And you do the same thing for another 4 years. At the end of that 4 years, you have it paid for because you have the rent coming in from the first one, the rent from the second one. You get good at doing your own maintenance so that you're not like paying for maintenance. And at this point, you're making somewhere around $7,000 net a month from your rental business. You're in commercial real estate development, and you're making somewhere around $7,000 a month from your job net after expenses. So you're clearing $14,000 a month. And things look pretty peachy at $14,000 a month. 3 months buys a pretty decent car for cash. 4 months buys a nice car for cash. You just walk in and you use the one payment plan. You test them out and you say, okay, well, I'll take this one. Here's a check. And the salesman falls off their chair because they've probably never seen that happen before. And you can leave with it. But the point of this is, at this point, let's say that the company that you're working for has a bad year and they lay you off. All of your friends are going to be going, panic. And you're going to be going, maybe I'll take the summer off and travel. Okay? You pay off all your debt, credit cards, mortgages, everything. And suddenly, that's your expenses and that's your income. And it doesn't take that much. This kind of a process, if you pay attention to the rules for how to become wealthy, can lead you to being what most people would consider rich in 10 to 12 years. If you're married, and you marry somebody that has a decent income and they're willing to participate in this, you can do this faster. Now, the reason I give you this illustration is because I think it's important that you understand that this is a possibility. Not just a possibility that I'm talking about, because I have done this. I have helped other people to do this, that had dug bigger, deeper holes in life. I'm helping my daughter right now to go through this process. She is somewhere out there in the first building paying it off, right here in Laramie while going to school. And yeah, it's taking her longer than 3 years, but she's also finishing a degree in molecular biochemistry while working through this process. But she's well on her way to financial independence and retirement in maybe 8 more years. And it's not a mystery. This can be done. Now, likewise in this class, if you go through and you do the homeworks and you do them on time, you're going to learn a lot. It's going to lead you to those kind of jobs that pay that kind of money. And it means that you're going to come out in a position to become wealthy in a short period of time if you apply the rules. If you apply the rules in this class, you're going to get a good grade. So applying the rules is a fundamentally important thing. Figure out what they are. Study them. Learn how to make money. And you're well off and well on your way to not just a nice job, but a fantastic lifestyle out of being in the computer field. Now, I went and did this. I already had property. I already had money when I built my first business. So by the time I was building a business, it was, what's the risk? I mean, unemployment? What of it? Take a year off? Oh, okay, I'll do what I want. So it removes the risk in life. It makes it an easy thing when, there's no pressure to do bills. Now, the first time that I heard this particular fact, I said, nah, that can't be true. But in the United States, 40% of people have less than $400 in savings. 95% of people will, at age 65, have less than the average 18-year-old in savings. So, this is the economic reality of not paying attention to the rules and not applying them and using them. And with that, I want to move on to a demo of, we can come back and talk about this one-on-one later or as a group. I want to move on to a demo of, where are we going with Python? What are we going to learn? Because it's a wonderful language. And when I do the demo, we're going to do that on the computer instead of in front of the light board here. But we'll work through a demo and show you where you're going to be in a few months with the language.